Welcome everybody to Novus Nexus product demo. We'll be showing an automated end-to-end simulation process. Now first, let's start with this general concept of the workflow for this automatic end-to-end process. So first thing I'll have you note is that everything in this yellow blue box here is the automated process. These component parts are set up beforehand to allow design engineers or analysts to be able to run multiple simulations across different CAD platforms and commercial and open source fluid and structural solvers with a lot of flexibility while maintaining robust, reliable output. So it will start with a simulation ready CAD model, which is a basic CAD model that's informed by some of this stuff under the hood with some simple text strings coming from the abstract model, string parameters that are attached to the CAD model. Now, a user will upload that CAD model through, in our case, ESA, which is a browser-based web app. And it'll go through that and automatically integrate with CA Nexus, which will take that model together with the abstract model, which is where all the physics is captured in a geometry independent way that can be reused multiple times. And together with the CAD model, the abstract model, CA Nexus will pump out the mesh and the solver input deck already attached to a simulation geometry for any number of solvers. Then automatically that will be fed through our report framework to a post processor of choice, which will then, once that's complete, automatically generate a user-defined simulation report and email it back to the design engineer or analyst. So this is the automated process. So first we'll jump in and just look a little bit under the hood to see what an abstract model looks like, because that is going to inform how you make your CAD model. So here is CA Nexus UI abstract model maker. So over here you see that there are classes, no physical geometry, just abstract placeholders, titles that will represent actual geometry. For example, you can see that we have designated here under this solid class specific material properties that are specific to the OptiStruct solver. Anyone familiar with that is already putting these properties every time they do a simulation. Here you can put it once on a placeholder entity called a class where these physics properties and attributes will be held. Other than that, we can also determine the output. For example, what kind of report we want generated and what we're going to be studying in a specific given simulation. This entire CA Nexus abstract model serves as a knowledge capture. So let's jump out from the abstract model and see how it's applied to the simulation ready CAD model. Here we have a PushBeam assembly in Creo for a dozer bucket in the front. You can see up here we have the main bucket assembly as well as these push beams. Some hydraulic cylinders are modeled in there. So over here in the model tree you can see that there are tags that we've placed, both simulation component and simulation class tags. So the S comp represents the names of each parts, where the S classes are those placeholders that come from the abstract model. Further, we've parametrically designed this CAD model so that the angle of the bucket assembly can be changed. That'll be important when we come to our automated simulation UI web app. So we're going to come out of that simulation model and go look at that web app now and see how we can run simulations given this abstract model and this CAD model. So here's a very basic structural analysis web app. So we can choose the CAD software, Creo in this case, version 7, the dozer assembly we were just looking at. We can upload it. We know that we're working in OptiStruct, so we've chosen that. We've also be able to change the angle of that blade on that front bucket assembly as we spoke about earlier. And you'll see that as we change the parameters on the blade position, the loading conditions for OptiStruct, for the static analysis, will change. So let's just plug that in so we can see. Now you can see the loading condition has changed to be greater than 0 degrees. and we'll put it back to 0, and that's what we're going to run this time. But just as an example, you could submit one, come back, change the degree because we've parametrically designed the CAD, submit another. So again, I mentioned that we're a static analysis type, but it's also possible to do modal depending on what you're looking for. So once we submit, let's show you from all the way through the end. So it gives us this message that it was submitted successfully, and we'll go into the dashboard to see what a user would see. So you can see here that it is now this new PushBeam structural simulation. The geometry is being prepared, and what that means is that if we were to look out at CA Nexus and what's happening under the hood, you can see that this simulation model here has been generated. This is all happening automatically with CA Nexus as a preprocessor, and that solid class with those material properties has automatically been married and put onto all of these parts highlighted here in the CAD model. These are those same properties that we defined and captured within the abstract model that we looked at earlier. But now, instead of applying them to each part, they're automatically applied to each individual part. So that's all happening automatically under the hood, as well as the mesh generation predefined. So once that CA Nexus has married the two, created the mesh, it'll push it out to the solver. Once the solver's done, that'll go through our report framework to a post-processor of choice and back to the designer via an email with a simulation report that's been designed in that output stage of the abstract model we talked about. So here you can see an example of the simulation report coming down, a number of contexts, product information. Okay, now let's get into the juicy stuff here. The model summary. It shows you, this will tell you which files, which were uploaded, which abstract model file, which CAD file, which solver was used, and the type of analysis, and which materials were being investigated. It'll also show you which components were assigned each material, so you can validate and verify, and what the constraints were and what the point forces were in this case along the bottom edge of that plate there at a 0 degree angle coming in. And after this simulation inputs, we'll be able to go see a little further down an example of the geometry and the mesh, as well as the displacement contour for this first load step, the stress contour along all those 3D parts, the stress contour along the two-dimensional inside surface of the bucket, as well as the strain, all under load step 1. And here's a brief animation also included in the report with numerical representations of the outputs as well. All of these report parameters are customizable and determined in both the abstract model and the automated process UI. I hope this goes to show just how an automated simulation process can facilitate correct design decisions. Model can capture and reuse the expertise of your analysts. A number of advantages are available here. Thank you so much for watching. If you have any questions or want to investigate how this could be used for yourself, please contact us through novusnexus.com.